Hi all, welcome back to the video lecture on computer network. In this video which we are mainly going to discuss on the congestion control in Datagram subnet. They have suggested this mechanism for handling the congestion control in the Datagram subnet. We will discuss one by one in detail. The first mechanism they have used to control the congestion in the case of Datagram subnet is setting a warning bit. Warning bit is nothing but setting a special bit in the packet header fed by the router to warn the source when a congestion is detected. How it will work? Once a packet will be arriving on the destination, the transport entity which will copy the bit to the next acknowledgement and it will send back to the source. Once the bit is arriving on the source, it indicates that a congestion is occurred. So then automatically the source will cut down the traffic. As long as the router was on the warning state, it is going to get the acknowledgement back. So once the acknowledgement is get back from the receiving end, that means the destination, automatically the source will reduce the data transmission. Then once the congestion is over, at that moment only they are going to increase the data flow. That's the mechanism they have opted in the case of warning bit. The second approach is to control the congestion in Datagram subnet by setting a chop packet. What exactly mean by a chop packet? A chop packet means it's a specialized packet that is used to control the flow in a network. So how it will work? Whenever a congestion is detected, it will send a chop packet across the network to all the data flows associated with the congestion. So once the congestion is detected, the sender host, they are going to receive a chop packet. So the sender host automatically reduce the transmission rate. So how the router will detect the congestion? So the router can detect the congestion by measuring the percentage of buffer in use or line utilization or average queue length. So the sender host will wait for a certain amount of time. So once the congestion is detected, it listens for any further chop packets are arriving or not. If any one chop packets are arriving, still it indicates that the line is congested. So it will reduce the transmission rate. This is the approach they have followed in the case of chop packet. The third approach they have used to control the congestion by setting hop by hop chop packet. Why they go for hop by hop chop packet? In a high speed or a long range distance, sending a chop packet to the source host which will not be work out effectively. So in that scenario, they have go for an alternative approach is that to have a chop packet take effect at every hop. Every hop means that every node it pass through. So let me explain with an example. In this example, when a chop packet is arrived on the node F, it will automatically reduce the data flow to the D. So similarly, when the chop packet is arrived on a node E, it will automatically reduce the data flow to F. Similarly, one more situation is there. When a chop packet is arrived on the node A, it will reduce the flow to E. So the entire data flow through A, E, F and D will be reduced. That's the approach they have maintained in the case of hop by hop chop packet. The fourth approach to control the congestion in the case of Datagram subnet by the mechanism of load shedding. The basic idea regarding the load shedding is that when a router have a lot of packets they cannot handle, if more packets are there in the case of a router, they will just throw them away. So from where the word load shedding is came. Load shedding is the word came from the electrical power generation, where it refers to a practice utilities intentionally blacking out certain areas to save the entire grid from collapsing on a hot summer day. When the demand for the electricity neatly exceeds the supply, at that moment they will go for the principle load shedding. In the fifth approach they have used to control the congestion in the Datagram subnet by the mechanism of jitter control. Jitter is that it's the amount of variation in the packet arrival time. That means a standard deviation. So how it will work? When a packet arriving on a router, the router check to see how much packet is behind or ahead the schedule. For the information they will update on each hop. So once the information is updated on each hop, it knows that each hop came to know that this much of packet is coming after a certain amount of time. So once the time duration will be there, the congestion can be reduced. For an application such as audio or video streaming, it does not matter if the packet takes 20 minutes or 30 milliseconds to be delivered, as long as the transmit time is a constant. So once the packet will be arriving after a certain amount of time, it's not a problem. The case of a audio or video streaming.